Hello and welcome back to this stream. So today we are going to try and code Toralizer. So this will be just a mask for our IP address, so that when you're trying to SSH into something, you mask your IP address. So normally a direct connections works like this. Your computer IP is exposed to a website you're visiting or something like that. So today we are going to write, let me make this window bigger. If I don't know if I can. Let me try. Oh. Yeah, so every other day when you access a website, your IP address is always exposed. So we're going to try and do a connection. Your IP address is always exposed. So we're going to try and do a connection. Your IP address is always exposed. So we are going to try and code a command line utility tool or library, not a command line program in Golang that is going to mask our IP address but via the Tor network. So you'll have your computer and your IP address, the traffic will be routed through an entry node and then through a relay node and then through an exit node, so that the external site will only see the exit node of the connections in the Tor network. So to start that off, I think let's go to the IDE and create a make file. So we want a command that will build our Go program. And how do we build Go applications? We'll just do Go build dash output and then the name of the binary. So for my case, I want it to be a Toralizer. So let me try and run make build. I know it won't work because we don't have any Go mod file and also I'm going to do a Go mod init here. I don't know if the fonts are visible, but let me see. Yeah, I think this is visible enough. Oh, I don't know if I can go to settings and try and increase appearance, editor, font. Let me put it size 18 and line height to 1.4. Apply and see. Okay, so we are going to do a Go mod init here. So Go mod init So what will we need? We need a main.go file. So in our main.go package main, and then func main, let's just fmt println hello world, and then make build. Yeah, the build was successful, and you can see the binary here. When I run ls, we can see our binary here. Yeah, so we want to be able to test get requests, post requests, and in the Tor ecosystem, there's something like circuit rotation. So when you, let's say you're making requests via Tor, and your the output IP address is already recognized, you want to change it. So you'll send a request to the via the client, so that the Tor network can change this for you. So test circuit. So let me just populate the let me populate the make file with all the functionalities we want this to have. So let's have test. We want to build it first. When we call test, what do we want to do? We want to build, and then test verify. So what will this verify do? We will verify that we are connected via the Tor network before sending any packets out, or before making any requests. And then we want to test get and test post, and then test the circuit. So how will our test get look like? We will be using this to test our, let's echo something to the terminal first. Echo and it will be our binary, which we named Toralize. And then we are going to request to this to this address. Toralizer. Yeah, so it calls the binary well, but the binary doesn't have a way of knowing. Still, our binary is still just printing hello world. So I want us to create a Go package and cmd. Yeah, let's create a Go package which will create the Tor client. So and here is where all the magic will happen. So we'll create a file and name it client. So we need some variables. The default address where so Tor always listens on port 9050. So this is where all the traffic will go through. So let's create a comment. So all the traffic will go through that, but it also has a control address. So you remember when I said that sometimes we would want to rotate our IP address. So we'll have the control address is always at 9051. So let's write a let's make comments there. So we'll call this to give us new exit IPs. So then we'll need a structure for our client. So what will our client have? We'll have a pointer to the HTTP client from the standard library, and then we will need a dialer, but this will come from the proxy dot. So that is the client configured to use Tor, but then we are going to use SOC 5 for raw TCP connections, because we want to be proxying our request. So we will need the dialer. So the dialer comes from the Golang package. Let me add it here. So our imports are growing, and we can do go mod tidy to bring that in. So we will be doing direct proxying and all that. So let's code a new client. So how will our function for new client look like? New client will take in a client and an error, not the signature that we being given here. We will take in a pointer to client. No, we take in nothing. So our new client takes in nothing and returns a pointer to client or an error. So what are we going to do? We initialize our dialer, comma error. It will use the TCP and proxy address. We will not have any auth, and then proxy.direct. So if the error is nil, we will return nil and error. So let's make some comments here. So the proxy socks creates a dialer that routes connections through a SOC5 proxy. So we want to wrap the SOC5 proxy into HTTP transport that now any HTTP request now will go through the Tor network. So let's create an HTTP client. Then transport will be HTTP transport, and then dialer, and then we will return then we will return now. We'll return our reference to client HTTP will be, let me see why it's, we'll return a client and nil. So HTTP will be our HTTP client, and the dialer will be the dialer. So I think the initialization of our new client is done. So I also said that so which methods will our client have? We need to verify that we are connected via the Tor network before sending any request, and so our client will need to have a function called verify. Let's call it verify, and it will take no arguments, and then it will return a string. It takes no argument, and then returns a string or an error. So what we will check is, we will check if the request is coming from a Tor exit node. So we'll have resp comma error equals to c.http.get. No, let me copy the URL. Then we check if error is not nil, we return an empty string and the error. Let's format the error. fmt dot error f. So we'll do cannot connect to Tor. So then for the response, we need to check. Let's defer the response.body.close, and then we need to read the body. then we convert the body into string. So here we're going to check if this came from Tor. And this is how we check this. We are going to return an empty string, and then we just tell the caller that this is not connected via Tor. So to verify further, we can extract the exit IP and just return it. We can exit. So this is the IP that the website will see. This is the IP that the client at the end of everything is going to see. So how do we do that? We'll have a start, which will be but at the IP. No. At the letter IP, and then we are going to add 6, the length, and then and will be at index body strings up to where we have this character. Then we are going to add start. Yeah, so this is start and end. We are just trying to come up with a place where we are going to slice the body string so that we get the IP address. So we are going to let's print printf and print the standard error and a message connected via Tor, and then we print the exit IP. Oh no, we did not slice the IP. IP goes to start to end, and this one throws an error, but we can ignore that error for now, and then we return IP and that. So Yeah, this is a verify function now working fine. Let's remove the import and let's sort the imports. Yeah, new versions of Go require that you sort your imports. So we are going to create a folder cmd where we are going to have our root.go file. So this is where our cmds are going to go. So we are going to have different commands. So we are going to have different commands. So I'm going to use the Cobra library for this. So let me do the imports. So okay, on the client we wrote that. Let's try also and do the request, and then we can test this, or which one is shorter. Let me see what's shorter to implement so that we can yeah. Let's work on the rotation. How do we rotate a circuit? Yeah, this one is really short. So the rotate circuit is not going to be a method of our client. It's going to be just an independent method on its own, which will find it will take nothing but will return an error. So we need to connect to connect to the control port, the top control port. So we need to connect to the control port, so that will just be, we initialize a con and then to the control address. If error is nil, we return the error. Or let's return something graceful. So what do? We defer the closure of that connection. Then we'll need a buffer. We don't need 1024, 256 will be enough. So we need to authenticate. When you send empty auth we can send empty auth if no password is set. So what do we need? Do we need our connection? Need to write to our connection. And what are we going to write? Wait, let's wait a minute. What do you want to do? Let's just print this for now. So that it stops screaming at us. Then we are going to do n, error. We read into that. If error is not equals to nil, we return. And then also we check if we are going to return that. No, let's say authentication failed. And then now we can ask for new identity. We ask Tor to build a new circuit. So we're going to write the signal write so here let's just handle the error. It returns a number. So let's just print that number so it stops screaming at us. Then do n and again if we return error and then we check strings. This one will be signal failed. Then we return nil. So we want to test this. So how do we do that? We'll go to our root file and create the root cmd. It will be cobra dot command. I think I can do a go mode tidy to bring that in. So we have this. So all these are required. A command requires all this, but we're just going to write a few, the use, the short, and all that. So there. It basically just describes what our CLI does. So then we are going to create the rotate command. What will this rotate command do? It will request a new so in short, new exit IP. Then what will be its run function. Need a comma here. So here we are going to check if what do we call? Yeah, we called the package door. We want to use this function. So door I don't know why it's not auto importing. Let's try and remove all those. Let's see. Yeah, so I'm going to Then we exit. If all is successful, we are going to have to print a line. So yeah, so the Tor network rate limits how frequent you can rotate the exit IP. So it waits for 10 seconds before this is done. So I think we can now let's write our execute function. And we can import our execute function into our main. Now instead of we just run that. So let's see if we can make build. Let's build it and then let's see if yeah, so circuit rotation complete, wait for 10 seconds before. Yeah, so these are just the random numbers we printed. Yeah, I think we should also print the new rotated IP. Yeah, let's do that. Let's see if we are able to print the no that will let's proceed and work on the verify. We are done with the verify. Let's proceed and work on the requests. Then we can work on the tunneling and test this if it works, if it really works. So let's go to our root file and that one will remain our client file. So we are able to rotate the IP. Let's remove this here. And also remove this here. That's nice, that's nice, that's nice. So yeah, let's add the test rotate to our make file. So let's make rotate our make test circuit. Yeah, that works. Make test get. Yeah, we've not added that, so that is what we're going to do next in our client. Let's put it here. So we are going to write a method for our client to make a request. Our request will take a method, URL and data. Then it will return an error. So since we are returning all strings from this, we can have that. So we are going to set up a request body there. Yeah, it will be an io.reader. So if the data is not an empty string, body will be strings.newReader, and then we read into that. Then we are going to create the HTTP request. So we are going to have request is equals to new request method URL body. If error is nil, we return. So if we have a body, we will assume it is in JSON. So if data not equals to an empty string, application JSON. So if we when we execute the request, like like that. This will go through the Tor network because the c.http uses our SOC5 dialer, and our SOC5 dialer was proxied through that. So if error equals to nil, we return error, and then we can stream the response. Yeah, we can defer body.close, rest.body.close, and then we can stream the response to the standard output. So we do io.copy. And then we return nil. So that's that. Let's go and now work on our package, the request CMD, and see what our request CMD now does. So let's do here so our request CMD will need some flags. Okay, let's write the request CMD first. And we'll need a URL. So short make a request through method will be method data. So what are we going to do? We're going to create new Tor client. We wrote then we exit. So to avoid accidentally like clicking your IP, we must make sure that we are connected, we are on the Tor network before we make the actual request. So that is where our verify function will come in handy. So if client.verify, who does let's see our verify function. It returns a string and an error. So the string is the IP. So we really don't need it. Error is not equal to nil. I'm going to exit, but we can get the exit IP here and print it. So then we can, I think it needs a comma. So we will make the request. Yeah, I think that is done, and now we need to add our flags for the request on our init function, and then let's build and test again. Let's update our makefile to test. I think now we can test get and post. Yeah, the program builds and make test get. Yeah, now you see, as you can see here, our exit IP is 185.246.190.8. so I want to rotate and then do the make get again. So make get, and then we can see, yeah, so our exit IP and then our new exit IP. If I do a make get right now, I think the exit IP is still the same, but then if I rotate and do it's different. Yeah, you can see it's different. So let me reply to some comments. Yeah, so you can see like we are able to mask our IP and then forward our IP through Tor. So I think we've gone for a very long time. We can what else can we do? We can even tunnel SSH via Tor, and I think let's implement that and then finish up this. So let's see how tunneling can be done. So we'll have a function of our client. We'll name it tunnel. It will take a target of type string, then it will return an error. So what do we want to do? We want to connect to the target via yeah, so this is interesting. We will need for you to tunnel, there is some magic that happens. You need to a bidirectional copy, because you will be copying in both directions simultaneously. So how do we achieve this? So let's connect to our remote. So if there is an error, we will return the error. If there is no error, we defer remote.close. So after that, I think we can print something to the screen that we are connected to, that the tunnel is open via Tor, because we are using our dialer. And so our first go routine, will be from our standard input to the remote. So we will do a go func yeah, and then our second routine will be from the remote to our std out. then yeah, let's just write the go func signature, and then we will need to return nil here, then wait for the done channel. So we are going to make a channel and then call it done, and it's a channel of structures. So when we get in our first one, we're going to do an io.copy from remote to std in. We're going to copy from remote to std in, then send it to done. Then for our second one, we're going to do an io copy from std out to remote, and then done. And yeah, I think that's that. So we've not handled errors on this, but that is not vital, so we can add this to our root.cmd. So we can have root.cmd.add you need to add the tunneling. Tunnel cmd tunnel command. So let's write our tunnel command. We create a new client. If error is equals to nil, we do that, and then os.exit. So if we will show the exit IP. So oh no, if verbose, first of all we verify. Then we do an os.exit. We need a comma here. If everything goes well, we open the tunnel. And std in, std out becomes the connection. So And let's test. Let's make build. We are able to build. Let's test. Test to verify. So that is that, and let's testing SSH. So if we do test it as ssh.var boss, let's see how verbose works. Oh no, I did not add the flags. Let's build. Then I don't know why verbose is not working. Let's try and so I don't know why the verbose is not working well, but that's that. So we've seen, so what have we seen so far? Yeah, we've seen how we can mask our IP address so that our traffic goes through the Tor network. So as you can see from the diagram, when you just make a direct connection, the person on the other end can see your IP address. But with this, we pass our traffic through the Tor network. So one disadvantage of this is it really makes things slow, because now you see a lot of hops. We must jump through a lot of nodes, like the entry node, the relay node, and then the exit node, so that we get to the end, to the other side, but with direct connection. So when so in software every day, when you make this kind of trade-offs, there is always something you give. So for here we are giving the fastness of this for the privacy that is going to come with it. So thank you so much, and see you in another video.